Bonjour, baddies. Welcome back to another video. Today's first question is, a garden is laid out in the fashion shown in the diagram below. If only the shaded isosceles right triangle are used for planting, then what is the total area in square feet that is to be used for planting? So when you first see this, I've drawn the lines in white, but they are meant to be there, and that's I think a pathway or something, but only the purple area is used for planting. So we're trying to solve for the purple shaded area. So the first things you guys see is probably, we should probably solve for it, right? And then multiply by 4. But to find the height of this area, we need to actually know what this center little area is, and that's extremely hard to solve for. But there are other ways we can do this problem as well. Like I said, I drew the lines in white, which makes it even more apparent that there are 4 very distinct isosceles triangles. And this means that we can press them, if you think about it, squeezing this triangle in, this triangle in, this triangle down, this triangle up, it'll make a square in itself. And this means that this square is the combined area of these 4 triangles, and the side lengths of this square is equivalent to 16, as said and shown in the problem. Therefore, the total area of these 4 isosceles right triangles is equivalent to 16 times 16, or 16 squared. And since 16 is 2 to the power of 4, this is basically 2 to the power of 4 times 2 to the power of 4, which is equivalent to 2 to the power of 8, which is also equivalent to 256. And feet squared. Yay! Moving on to problem number 2. In triangle ABC, we have angle A is equivalent to 30, angle B is equivalent to 60, and line AB is equivalent to 8. So this is a right triangle because 30 plus 60 is 90, so the other angle must be 90. So our triangle should look something like that. Let me just mark this real quick. So A, B, C. So A is equivalent to 30, B is equivalent to 60, and AB is equivalent to 8. Find BC, AC, and the area of triangle ABC. So if we want to find the area of triangle ABC, we obviously need to know the height and the width, right? And let's just deem this our height and this as our width, which is also simultaneously solving the other part of the problem, which is finding BC and AC. And this has sort of a formula behind it. There were a couple problems before this that kind of explain through it. But basically, in a right triangle with the angles, well, as the book called it, as a 30, 60, 90 triangle, this angle, it always has a 1 to square root of 3 to 2 ratio. And what I mean is, here is basically our 1 ratio, this is our square root of 3 ratio, therefore this is our 2 ratio, the hypotenuse is always the longest. So this means that the 2 times 2 times something, aka what this side is equivalent to 8. Therefore, this side is equivalent to 4. And similarly, this means that this side is equivalent to 4 to the square root of, no, not 4 to the square root of 3, 4 times the square root of 3. And therefore, now that we know these 2 sides, we just need to find the area of our triangle, which is basically equivalent to 4 times 4 to the square root of 4 times the square root of 3. I legitimately can't say that for some strange reason, which is equivalent to 16 square root of 3 divided by 2, 8. Therefore, the area of this triangle is equivalent to 8 square root of 3. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, and I will see you all on the next one. Bye-bye!